Hi, welcome back to LeetCode. In this we discuss LeetCode problem 3411, maximum subarray with equal products. So you are given an array of positive integers nums. So an array is called productive equivalent if the product of the array is equal to the LCM of the array with multiplication of GCD of the array. So product of array represent the product of all the elements that is present in the array, and the GCD of array means the GCD of the GCD of all the elements that are present in the array. Similarly for LCM also, LCM of the array will be the LCM of all the elements present in the array. So we have to return the length of the longest product equivalent subarray. So this actually the problem statement is simple, that we will like what will be the brute force approach. Like for this is our input array. So and our answer will be initially 0. Now what will be the brute force? The brute force will be that we will generate all the possible subarray from this input array. Now for each subarray we will check that current subarray that we are going to check, that actually product equivalent or not. So how actually you can check? We will just multiply all the product all the elements that is present in the array, that subarray, and we will take the GCD of also and the LCM also. Now what we will do? We will just check that the product value, the product of the array is equal to the LCM of the array into the GCD value of the array. If it is equal, that means this is a product equivalent array, that subarray. So now what will be the length of the, now we will take what is the length of the subarray. Now we will take the length of the subarray. Okay, now we will check the answer, the maximum subarray, whatever we have seen till now, the answer variable it will store. So if the current length of the subarray is greater than the length of the subarray we have seen till now, then actually we modify the answer variable, and ultimately after checking all the subarray we will return the value of the answer, whatever the actually the product equivalent array actually we have seen length of that, it will store at the value of the answer. Now so what will first initially it is 0 answer variable, it will actually ultimately store the length of the product equivalent subarray. Now we'll generate all the possible subarray, like first it will be 1, then 1 2 1 2 1 1 2 1 2. In this actually it will generate all the possible subarray. Now suppose for this subarray I want to check that this is actually product equivalent or not. So what I will do, I will first find the product of this. So product will be 1 into 2 into 1 into 2, correct? So the product will be 4. Now what will be the LCM? LCM is the least common multiple factor. So it will be 2, because 2 will be divisible by all the elements, like 1 will be also divide 2, 2 also can be divide 2, so that's why LCM will be 2. Now GCD will be the common value that is actually divisible, so the GCD value for this array will be 1. Okay, now we will check the product value 4 is it equal to the LCM value and the GCD value. 4 equals to 2. No, this is not equal. So this is, we will not check the length of this subarray. Okay, we will go to the next. In this way actually we will generate all the possible subarray, correct? You already know how actually you can generate all the possible subarray. So we will take 2 pointer. One pointing is pointing to the starting of the subarray, and another is the pointing to the current ending of the current subarray. Okay, so from L to R whole subarray I will generate all the possible subarray, and actually I will shift the rightmost pointer to the right. In this actually generate suppose 1 2 3. So L will be point here. So first R will be point here also same. So our array will be 1 subarray. Now I will point to the R will be shifted to here. So our array will be 1 2, because L will be still pointing 1. Next I will shift the R to here. So it will be pointing 1 2 3. So after completing of the R, I will shift the L here. Okay, now L is pointing 2, and R also start from here again. So this will be 2. Next I will shift the rightmost pointer to the right again. So this will be 2 3. In this actually we can generate. So the time velocity for this generator of the subarray, the time velocity will be big of n square, because we are taking 2 pointer for each pointer I am actually iterating all the elements of the present in the right side. Again I am shifting the left pointer to the right side once, and again I am checking all the possible elements. So that's why if the length of the input array is n, then we are for n for the left pointer, and for right also we are taking n minus 1 in this way. So n into n minus 1, ultimately approximately it will be n square. Correct? This approach is like you all know that. Now why actually this then what we will just whenever generating the array, we will do what? We will take three variable. One is for product, and another for the LCM, another for the GCD. So after each subarray, we will check the current product is equal to the product of the LCM and the GCD. If it is equal, then I will have actually get the length of the current subarray. I will get r minus l plus 1. Then I will, if it is equal, then actually I will take the length of this current subarray and check with the answer variable. If it is greater than that, we will actually modify the answer variable. Okay. Now for there is actually one thing actually here we have to observe, like the product variable. So LCM and GCD will be within the always range, because the number will be always approximately the number present in the array. Now the product variable, what will be the product? Product will be always, it will be increasing, or at least it will be not, it will decrease, right? It will be always increasing, or it will be equal. Like we have suppose three elements 1 2 3, then what will be the product of this? Product will be 1 into 2 into 3, that's 6. Now what is the range of this? Like they mentioned that the input array length will be 100 and the value of each element can be 10. So first array, that is actually the whole input array, whenever considering this as a sub array, then the what is the maximum value it will be possible? 10 to the power 100, because I am taking the product for each number. Suppose all are actually maximum and the length are also maximum. So this the number of numbers of present will be 100. So that's why it will start from 0 to 99. So that's why if I take the product, then it will, what will happen? 10 into 10 into 10 into 100 times. So that's why this will be 10 into 10, 100, 10 to the power 100. So that's why this will give the that is a error, that we can't actually store this value, this large value. So that's why what actually we can actually optimize this here. One trick actually here is that if we use the log here, so ultimately what we will check, that the product of array will be equals to LCM of A into GCD of A. Now if I do the log of this, so log of product A equals to then it will be log of LCM of A into GCD of A. Correct? This is, we can write this if we take the log both side. Now what we'll do, suppose there are actually n elements, so then the log actually we can write here actually log of A1 plus log of A2. In this actually it will be, I can write it as a log of AN. There are n elements, and for the right side actually we can write it as log of LCM of A, array A, plus log of GCD of A. We can write this because what is the log properties? Log properties is that log of A into B, we can write this as log of A plus log of B. Correct? This we can write this. So this property actually I be used here, because here actually we have two product, LCM of the array and the into GCD of array A. So if I take the log of this, then actually we can write this as log of the LCM plus log of LCM plus log of GCD. Here actually we have converted to plus. Now here actually you can check that in the left side also the product of this also have been converted to this log of in the base of log. So this will actually we are taking the sum of here actually we are taking the sum, because if there are actually multiple n elements in the array. So if I do the again same properties, A1 into A2 into AN, we can write it as log of A1 plus log of A2, in this way log of AN. Correct? So that's why I will just add the all the log value of the current value. So here actually it will not give the overflow, right? So that's why this is the trick here actually I have used to handle the overflow. So here actually the answer variable will be initially 0, and I am generating a 2 pointer. Here actually this is the left pointer, that is starting from I is equal to 0, I less than nums dot size, it can go up to n minus 1 left pointer, and taking the initially the product value will be 0.0 because the log value can be decimal value, right? So point, so that's why we have initially value is 0.0, and the initial value of GCD and the LCM value is the nums of I. Now I am starting a new subarray that is starting from j is equal to I, and j can go up to n minus 1. Okay, so what will do, I'll just add the product. Here I have already mentioned why actually I'm taking the instead of the multiplication value, I'm taking the addition value because of the log. Here I'm taking the log value of the nums of j current value, and I'll add this into the product. And GCD also the same. I'll call this inbuilt function GCD. I will pass the current GCD value, initially it is nums of I, and the current element in this in the subarray. Similarly for a LCM also, I am call this this in this function, and that actually I am taking two variable a and b, and I have to return the LCM value. So how actually I can do this? A by GCD of a comma b into b, correct? This is actually the thing. The LCM value is a into b by GCD of the a comma b. So that's why first I have divided this, then actually I multiply this. This is the same. So similarly for the current LCM value and the current element, I have passed this into this function. Now what I'll do, I have to check this current subarray is actually product equal or not. How actually we can check that? So I will do that the product value here actually is log sum, log of a1 plus log of a2. Now that's why the product sum, okay, that will be actually equal to 0 ultimately. So that's why I am checking that it can it can be actually decimal value, some decimal value can be present. So that's why if it is less than equal to 10 to the power 9, 10 to the minus 9, then actually we can check that, okay, and actually say that this is actually equivalent. So how to do the product value minus the log value of the LCM minus log value of the GCD. If this value is less than 10 to the power minus 9, then we can say that this is actually equivalent, product equivalent subarray. So that's why I am checking the product minus log of LCM value plus log of GCD value, then whole sum actually subtracting this from the product log value of this product. And if it is less than 10 to the power minus 9, then actually you can saying that, okay, this is equivalent. So I will check the length of this current subarray, j minus I plus 1. This is the current subarray length, and I check compare this with the answer variable. If it is modify this again if it is actually greater than the current answer value, and ultimately after all of this I will return the answer variable here. Current this actually trick, actually the log actually algorithm actually I have used here. This is the trick. Otherwise this is actually the brute force approach, correct? Why actually I have actually used log here, I have already explained. Otherwise if we don't use that log, if we just do the product, then actually give the overflow, because the maximum value can go up to 10 to the power 100. That actually can't store any long also. Okay, so this is clear. If you have any doubt, any suggestion, you can comment on that. And if this explanation is clear, and if you not yet subscribed, please subscribe the channel. Thank you.